Hello. It is high time we begin with the second gas law, which is the Charles law. Don't forget, I still remain your tutor, Prince Obajowo Daniel D. Nicole, also known as the mathaholic arithophysical biologist. So, in conjunction with BIA, which is the Boma Intellectual Academy, I kickstart the lecture. So, what is Charles law? Charles' law states that the volume of a fixed mass of gas is directly proportional to the thermodynamic temperature in Kelvin, provided the temperature is kept constant. I repeat, Charles' law states that the volume of a fixed mass of gas is directly proportional to its thermodynamic or absolute temperature in Kelvin, provided the the pressure is kept constant. So mathematically, we can say V varies as T. Now, transforming this relationship into a mathematical equation, we are going to have V being equals to what? KT. So our goal here is to make K separate a formula. Doing so will make us to divide both sides by the coefficient of K, which is what? Which is T. So that gives us V over T equals to what? KT over what? Over T, where T cancels T. Then K will be equals to what? V over T. Now, due to the changes in volume and temperature, our K can also be equals to what? V1 over T1. It can also be equals to V2 over T2 and so on. So for mathematical sake, we can actually pick two sides of this equation. On that note, we can decide to pick V1 over T1 being equals to what? V2 over what? T2. So this is the equation representing Charles' law, where V1 is the initial volume, initial volume, initial volume. T1 is initial temperature in Kelvin. Don't forget, in Kelvin. V2 is the final volume, final volume. T2 is what? Is the final temperature in Kelvin. I believe you are following through. Which means that whenever you are given the temperature in degrees Celsius, you can actually convert that to Kelvin by adding 273 Kelvin to the value given to you in Celsius to convert it to Kelvin. So, but then you may decide to represent Charles' law graphically. Charles law can be represented graphically by considering this graph I am actually presenting here. So pay attention as I present it. So remember, since the volume is directly proportional to the temperature, it means the graph will be an increasing function. So we have the V here and we have the T here. So it can go this way. That is, as the volume increases, the temperature actually increases at the same time. Are you get what I'm saying now? Or you can actually present it in this way. Pay attention to this. It can be in this way, where you have your V here. We have the origin, which is 0 degrees Celsius. Then we have T, and we have minus what? 273 degrees Celsius. Then the graph can go this way. So these are typical ways of representing Charles' law. But there are some things you need to put at the back of your mind when discussing Charles' law. Now note that the temperature at minus 273 degrees Celsius is called the absolute zero temperature. And this is the temperature at which the molecule of the gas have no volume. Note that. And at this temperature, the molecules of the gas also have no kinetic energy. That is, there is no velocity experienced by the molecules. And practically, at this temperature, there is no pressure since there is no kinetic energy, since the molecules are not in motion. So, I believe with this point, you should be able to actually theoretically express yourself when it comes to Charles' law. Don't forget, I still remain your tutor, Prince Obajowo Daniel D. Nicole, also known as the mathaholic arithophysical biologist. Stay tuned.